Okay, good morning, everybody. We're going to try this again. OBS keeps crashing today, and it's not fun. Anyway, thanks for joining me. Today we're going to be going through a little tutorial about how to actually segment out a patient's airway. A little bit of background on this. So this is one of the airways that we have in the lab. It's pathologically normal. It's taken from patient CT. We use these things for training medical students and residents alike. Mainly for gross anatomy. So we tell them this is what the trachea looks like, this is what right and left main stem bronchi look like, etc., etc. But primarily we use these things as actual functional training simulators. And what I mean by that is we actually use our airway models, both pathological and non-pathological, as example models to teach bronchoscopy. Either navigation of the upper airways with the bronchoscope via monitor feed and the actual bronchoscope itself, or by double lumen intubation or lung isolation strategies. What that ends up looking like is actually like this. So as you can see with our airway holder, that's actually again taken from patient CT. So this is the upper chin and the chest. There's the airway sticking out. And there's Dr. Maneri conducting one of the validation experiments that we're currently doing over at the lab with a 37 French left double lumen tube, bronchoscope in one hand, and then one of the lung isolation, either Easy Block or Fuji. I forget which one we were doing on this day. But as you can see, because of the material that we chose, Ninja Flex, and we'll get back into that again in the later part of this video, we're able to stick a fairly large gauge intubation tube down the airway, and then insert the bronchoscope, and then also do lung isolation. And what this ends up looking like on screen, oh, there it is with the bronchoscope all lit up. Very nice. What this looks like on screen through the eyes of the bronchoscope is this. As you can see the rings of the cartilage up here. And then your actual blocking half is here. Why is this image like this? Because I had to take it with my iPhone. This is a direct capture straight from the monitor itself. We couldn't take a screenshot because the computer for this particular monitor that we were using that day was just not having any of it. So there you go. We're down to the, I believe this is the left-hand side with the block. This is the easy block inflated by 5 cc's. So this is a left-sided lung isolation. All right. Yep. There it is. The right's now inflated. It's hard to tell here. Left main bronch. And then the right upper lobe, left main stem, right main stem, and then more intubation pictures. But as you can see, it's actually somewhat reminiscent of an actual airway and how you would perform this procedure. So today's little demonstration is going to go through the exact same tempo as before, just shorter. And if not shorter, then I'm going to split it up into 3. I'll apologize right now for making that last video like 48 minutes. To those of you that actually made it through all 48 minutes, thank you. I'm going to re-upload it probably at a later date into thirds or something not insane like 48 minutes. Okay, I'm going to stop talking. We're going to go through the overview of ITK-SNAP and how to actually get your segmentation out from here. From there, we're going to do some fairly heavy editing inside of Mesh Mixer to get it so that we can actually intubate these things. And then today's slicing is going to actually be done on Slicer. This is the preferred slicing program within our lab that produces a .g code file, and we use this almost all the time. Wow, I'm at a loss for words today. We use this basically for every single one of our segmentations that we use for our FDM machines. Yeah, that's it. So first things first, let's open ITK-SNAP. I'll walk you through the actual file opening procedure in this. The data set that I'm going to get, or I'm going to be using today, is from osirix-viewer.com/datasets. I'll have a link below in the description exactly to where to get that data set. I would show you where it is online today, but I actually do not have internet access right now. I'm up north. Okay, let's go. File, open main image. If your program looks like this, that means there's a bug, and I'll show you the bug. I can't click on any of this. So to actually open my image file name, I have to tab over to Browse, and once it's selected, it looks blue. I hit Enter, and you're just going to hit Browse. Find this particular data set that you're going to download. if you'd like, or you could just follow along with your own data set. The process is going to be the same. Today, I actually chose this one from osiris-viewer.com/datasets. It's the CARCINOMIX one. It's got a lung carcinoma. It's not the best data set to actually be doing this with, but I'll explain why I chose this one in a second. So to open your segmentation file, so go dig down through the entire folder until you see the DICOM files. Select the first one on the list. That's going to be your main image. Hit open. And then you're going to hit, there's a button here. It's going to be fairly obvious for you to, it's either going to be like open or import. I forget which one because I don't have that button. I'm just going to tab over to some invisible point and hit enter. Once you see that, just hit enter again past the screen, unless you have a button, if you're lucky. Sorry about that. Okay, I guess while it's loading, I'll take a second to tell you why I chose the CARCINOMIX dataset. The CARCINOMIX dataset is a full patient CT comprising of the chest as well as the abdomen. This isn't exactly ideal for getting the airway because it's not as specific as certain datasets would be. Ideally, you only want the chest so that you can get a pretty high res and focused image on the actual airway. The reason why I chose this one today, though, is because, for general interest's sake, this file has a good example of a lung carcinoma. So as you can see here, it's fairly large, and I think it's actually metastasized a little bit on this side too. So if you were interested in trying to pull out the carcinoma itself within the lung, I would encourage you to do so as a little experiment, and just to see what that looks like in 3D. I think that that's a pretty good exercise because it's already pretty well isolated by itself, and there's no real tricks to it. But yeah, if you wanted a little bit of extra training, you could try and pull this thing out. But today we're going to focus on the airway. So a little brief overview of the airway anatomy that we're particularly interested in today, for the purposes of like a bronchoscopy simulator anyway. Of course, there's a trachea. So this is the trachea all the way down. It's going to be this black void. Past the trachea, you're going to see the point of bifurcation here, splitting it up into the right main stem bronchus and the left main stem bronchus. And the right and the left, you have to be cognizant of which side that you're on. They are not mirror images of each other. They have different anatomical regions. The left one's the easiest one to explain right now. So the left one will bifurcate into either your left upper lobe or left upper bronchus up there, and your bottom one will be just the, you guessed it, left lower. So it's got two. So left main stem, left upper, left lower. We're interested in all those things. Past that point, it becomes actually rather difficult to generate any sort of like secondary or tertiary or quaternary bronchioles, just because the resolution of this particular CT isn't, fantastic for this purpose. But your mileage might vary on what kind of CT files you're playing with. But for us, it doesn't really matter so much today because we don't put the bronchoscope down that far. Like it just can't fit anyway. So the bronchoscope usually just stops inside the left main stem bronchus or the right main stem bronchus, such that you can see into the left upper and left lower or the right hand side's equivalents. So that's usually where we as a lab tend to end these things. If for some reason we are asked by other doctors to go further down, then we can go further down with a little bit of work. But for today's tutorial, we're just going to keep it nice and simple. So that's the left. On the right hand side, it's just like the left with the right upper and right lower, but it's also going to have a right mid. So again, point of bifurcation right here. This is your right main stem segmenting into the right upper. As you can see here, it's fairly obvious. And then as we scroll down, I think it's right, yeah, somewhere here. One of these is going to be left mid, or I'm sorry, the right middle, which is I think here, and this one's going to be the right lower, which is I think here. That'll become far more plainly obvious once I actually do the segmentation. Okay, let's get started with the segmentation. We're going to start at the very top of the trachea and then work our way down, splitting off to the right main stem and then left main stem bronchus. And then I'm going to just keep pointing out anatomical features as we go, just to keep us focused. So I'm pretty happy with where we're going to start right here. So once again, we're going to do this all semi-automated today. Absolutely zero manual tools, because you know what, we're just not going to need it. So step one, isolate where you want to start. So 1 on your keyboard or the crosshair mode up here on your main toolbar. Click where you want to start. That's automatically going to zero you in on all 3 axes. And then we're going to go into our active contour selection module. So 5 on your keyboard, or just find the snake guy with a pin through him. If your ROI is like something insane and just, wow, emails. If this is just something insane and just totally gone, again, hit reset ROI. It's going to encapsulate the entire CT slice. And then what we're going to do is zoom in or isolate our region, in which case it's the trachea. I'm going to do it for all 3 slices or planes. That looks good. And unlike last time with the mandible segmentation that I originally did the other day, we're just going to get the entire thing. I'm going to break that rule just because the trachea and the void that we're actually going to be pulling out is such a low Hounsfield unit relative to the soft tissue or bone surrounding it, that it's basically going to be isolated by itself. And you'll see that more clearly in a second. So once you're happy with your region of interest segmentation, you're going to hit segment in 3D. And then we're going to go to our window, the second one down here, that sets our boundary conditions again. So in step 1 of the active contour segmentation, we're going to set our threshold value so that this is isolated from all this other stuff around it. So in order to do that, we are actually going to set our lower threshold all the way down to negatives. And then your upper threshold, you're just going to lower it up until the point where you feel like you have a good isolation of the trachea. And this looks good. So my values for lower threshold is jacked all the way as far down left as you possibly can. And then your upper threshold, right now I'm using negative 332.0 as my Hounsfield unit variable. Doesn't really matter. Whatever you feel like gives you a good segmentation out of this. Remember, this is just the void of the airway, not the cartilage in any way. So I'm pretty happy with that. Hit next on your keyboard. I'm going to maximize this, I'm sorry. Hit next on there, and then we're going to grow the bubbles. You only need 1, I'll show you. So you need 1 because it's already such a high contrast and isolated segment of the body that you can get away with 1. So place that wherever you'd like in your airway. Hit next, and then we're just going to let the whole thing grow. This is a pretty quick segmentation tutorial relative to all the other ones that I'm going to be doing. The mandible was even going to take longer. That's not great. So if this happens to you, we're actually going to go back. We're going to go back all the way back to our pre-processing stage. I'm going to look for the point of connection right there. If that happens to you, continue scaling down your upper threshold so that we don't get that connection anymore. Okay, go back through, and we'll tell it to grow. And we're going to watch it again. Should be fine this time. Okay, so unlike the mandible tutorial and the following ones, which I'm pretty sure is going to be a cardiac one, it's going to be forever. The airway segmentation is actually really relatively quick. Most of the time spent here for this tutorial is going to be inside Mesh Mixer to show you how we actually do the 3D editing for this. Okay, that looks like a pretty good trachea. I'm at iteration 522. Hit finish, and then let's check our work by hitting update on the bottom left hand panel. And perfect, we got it right down to the bifurcation. That looks pretty good. Yeah, I'm happy with that segmentation. Okay, so let's choose left or right. I'm going to go to the left first because it's the easier one to do for me personally. So again, when we're going down the left main stem bronchus, we're going to be cognizant of the fact that we're aiming for 2 particular landmarks. In this case, you're going to be looking for the left upper and the left lower point of bifurcation. Those landmarks are going to be typically used when you're doing a bronchoscopy or lung isolation strategies, just so that you can point out where you are in the lung, or in the upper airway, sorry. So once again, we're going to zero in on the left using our cursor mode. Click down somewhere into the left main stem bronchus. Open up your semi-automated active contour selection mode. And then we're going to move our region of interest to where we want it. And isolate. Once you are happy in all 3 planes, we're going to segment in 3D, and we're going to do the entire thing again. So just like the bone, we don't need to keep playing with the thresholding levels right now. We're just going to tell the bubbles to grow. Okay, nice and quick. I'm at iteration 300, and I'm pretty sure we've captured the entire left main stem, and we can begin. Okay, hit update. Yep, and we captured a little bit of lung here. It's not ideal, but it's not the end of the world. We can remove that in post-processing later. But this would be the left upper, or the beginnings of it, and this is bifurcation to the left lower. So let's just extend these two parts a little bit further, starting with the left lower. Isolate it, segment in 3D, put your cursor over it, add your bubble, hit next, let it grow. Fairly small region, and we got some lung. Let's see how bad that is. Hit finish, hit update. It's not terrible. It's easy enough to remove later on that I don't really need to go back into the segmentation menu and do it. You could, of course, but it's just going to be faster for me to actually remove that later on. I hate that my window keeps resizing itself. So at this point, you have a couple of options. You can continue to trace down the left lower. There's a major dropout at this point that it becomes pretty much ISO environment with the rest of the lung. So it becomes kind of difficult to trace this up any further than what I can right now. You can do it with manual tools, but for our purposes, we're really just interested in the point at which it bifurcates, because we're not going to stick the bronchoscope any further down than usually the main stems. Nor are we going to do any lung isolation strategies at the secondary, tertiary bronchioles anyway. So as long as this particular landmark is in place, it's good enough for our purposes. For yours, it might be a little bit different, and you might need to go down further into the secondary and tertiaries. But we're not going to do that today. Okay, let's flesh out the left upper a little bit more, if we can. Left upper might be a little bit tricky. Yeah, I think that might be the actual maximum that we see for this particular CT file. It's not spectacular, but at least you get the idea here, because it branches off at that point to your left upper lobe. Get a little bit more here, I guess. Would I? Be a little bit messy, and chances are we get a little bit of lung, but that's okay. All right, we'll get it. So find your region of interest, position it over the remaining left upper, and then cross your fingers. Let's see. This might be a little bit too thin, and we're definitely going to pick up a little bit of lung here. Yeah, it's not going to pick it up. That's okay. Cancel segmentation. We're going to leave that and say that that's our left main stem, heading into the left upper and left lower. So now let's work on the right side. So bifurcation, right main stem, and then again be aware that we're looking for 3 anatomical regions here. So right upper, and it's fairly obvious because it's literally pointing up. And then the 2 trickier ones are going to be the left, or I'm sorry, the right mid and then the right lower. So this would be the right mid, it looks like, and then this one looks like it'd be the right lower. Something like that. We can double check, or this might be the right lower. We'll know more when we actually do the 3D segmentation. So once again, zero in on the right main stem. Find your region of interest. So I see it here, but let's pretend that, oh, I don't see it, it's gone. Reset your region of interest so that encapsulates the entire CT slice. And then pull in your bounds such that you've isolated your region. Okay, we're actually going to just do the main stem right now, focus in on that, and then from there we're going to branch off into the right upper. But we're going to do this stepwise, just so that it's nice and accurate. That's pretty good. Segment in 3D, segmentation window, hit happy with that, hit next, add your bubble, let it grow. We shouldn't get any lung, we shouldn't get anything other than the actual right main stem and probably a little bit of the right upper, but that's okay. In fact, that's what we want. Let's check our work by hitting update. Good. So it's already starting to branch off, and you can start seeing where it's going to branch off into your mids and your lower. Ooh, that's a crazy orientation for this. There. Okay, let's keep going with the right upper because we're already there. How far can we get this? Oh, we'll see. Segmentation window again, and then we're just going to complete that process. So we're going to pull in a little bit of lung here. Not spectacular, not happy with that. But this is one of the problems with this particular data set. That's okay. And we're going to stop it there. Iteration 109 for all of you that can't see that number. So that's the right upper. I'm going to stop it there just because any further and we get a lot of drop off from the CT. It's a slight hint there, but honestly we don't even need to go that far to make a bronchoscopy simulator, at least for our bronchoscopy simulators. Maybe somewhere down the line we will be. Okay, let's work on the absolute pains that are the right mid, right lower. Segmentation window. There you are. Okay, let's do this properly. Oof, why did I do that? Okay, that worked out. Exercise as much patience as humanly possible at this stage. Don't just try and get it all at once. There's a little bit more there. See if we can actually get that little bit. We're going to have to mess with our thresholds a little bit just to give us a little bit more play. How's that look? Much better, much more flushed out. Okay, let's follow that left mid if we can. Or left lower, sorry. Or right lower, wow. I clearly did not have enough coffee. Okay. Sorry about that. We're just going to finish off the right lower now. It must have been a really weird transition there. Okay, so region of interest again. We're going to isolate the right lower and all three quadrants here. All three quadrants. That is the wrong way to explain that. All three slice planes. It's better. Okay, once we're happy, segment in 3D once again, and I think you guys get the gist of this process. Isolate, add your bubble, your region, and then just let it grow. We're going to get a lot of lung in this one. Good. Let's see how disastrous that was. That's quite a lot. We don't really want that. So Control Z to undo and then update to see the results from before. And then we're going to do that again. This time, being a little bit more careful. So that's the connection point. We might have to just cut this one off early. Something like that will work. So my upper threshold is now -487, and it still does attach, but we're just going to make sure that our segmentation doesn't get too far that we grab all the lungs in this CT. So add our bubble, size it appropriately, and then we'll just watch it like a hawk. And yep, it's lung, so we're going to stop there. Finish. Updates. That's much better. We can actually remove those in post-processing. So as you can see, we've gone pretty far down into the right lower bronchial. We've got the right mid and then the right upper. Those are the main landmarks that we're looking for there. And our left side is equally as complete. We've got the left upper and the left lower. So for all intents and purposes, if we're just making a bronchoscopy simulator, as I'm demonstrating today, this is good. And now we just need to head into post-processing. So from here, I'm going to export out my STL, export a surface mesh, and name it.